This is the Chapter 4.1 lesson notes. I've already done the warm-up. Your objective today is I will use slope and y-intercept to write equations in slope-intercept form. To start off our notes, we're going to write an equation of the line with a given slope and y-intercept. We're going to use a form y equals mx plus b. This is the slope-intercept form. So whenever we're given this, if we're giving a slope, so the first one, we're going to say our slope is 3, and our y-intercept, I'm going to shorten that to y-int, that's how you'll often see intercept shortened to 8. For these, whenever we're kind of looking at this, we're given this general equation, y equals mx plus b. I'm going to write that equation over and over and over again. That way I just make sure that I have it in my mind whenever I'm working with it. And whenever we do this, the slope is what we call m. And our y-intercept is what we call b. So in plugging this in, I get y equals, my m is 3x, and then I pause before I write the plus, and I look at, is my number positive or negative? If it's a negative number, I'm just going to write a minus, and if it's a positive number, I am going to write that plus, so plus 8. Number 2, we have a slope of -4 and a y-intercept of 0. And so I have y equals mx plus b. This is my m, this is my b. So my y equals -4x plus 0. You don't have to write the plus 0 if you get that. However, if it helps you with just kind of making sure that you get everything right, that's totally fine. And you would finish that off as writing it as y equals -4x. Number 3, we're given the slope is 0. And we're given that the y-intercept is -2. So this one's a little bit different. However, we still follow that y equals mx plus b idea. This is m and this is b. So our y equals 0x, and then here we have that minus that I was talking about a little bit earlier, and so that changes to a -2. 0 times anything is 0, so I'm actually going to rewrite this as y equals -2. And this winds up being a straight across line. And just as a little reminder, slope is m. And the way that we find a slope, or m, is the rise over the run. So y2 minus y1 over x2 minus x1. Where we see that is here in number 4, where we're given a graph where we have a couple points, 0, 3, 1, 2, 3. So we're told 0, 3, and 2, 2. 1, 2, 1, 2. 2, 2. And there's a line that goes between those. That's totally straight. So whenever I find this, whenever I'm finding this equation in slope-intercept form, I know that it needs to look like this in the end. I know it needs to look like y equals mx plus b. I kind of go in order of things. I say, okay, I don't need to find anything for y. I need to figure out what my m is. And that's typically going to be your hardest part of this. So your m is that y2 minus y1 over x2 minus x1. And like I said before, whenever we kind of did this a little earlier in chapter 3, whenever we did this, I said that we can kind of arbitrarily name them. And so I'm going to name this one x2, y2, and x1, y1. And you'll see a little bit why I just did that. So my y2 is 2 minus my y1 is 3 over my x2 is 2, and my x1 minus my x1, which is 0. And what that gives me is -1 over 2. And so my slope is negative 1 over 2. Now, we're not done yet, because what we're doing here is we need to solve this y equals mx plus b. So now we have this y equals, our m is negative 1/2 x, but we still don't know our b. Our b is, when the x is 0, what does y equal? Now in this case, it actually already gave it to us. It already gave us a spot when x is 0, what was my y? And so I write that in. So I go y equals negative 1/2 x plus 3. And in case you missed that, it's up here on this graph where it has this x1. Our x1 was 0, and so our y1 was 3. That's where we got that 3 from. All right, number 5. If I'm given a graph, let's see, 0, 1, 0, 1, and then 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. And there's a line that connects those. I know that I need to get it in y equals mx plus b format. I need to find my m. I'm going to call this x2 and this one y2. And then this one x1, y1. So y2 minus y1 over x2 minus x1. Replace some stuff. So y2 is 3 minus y1 is 1 over, oops, I did the x2. I do that. All right, let's try that again. 5 minus 1. And then x2 is 3 minus x1, which is 0. All right, so 5 minus 1 is 4. 3 minus 0 is 3. And so my slope is 4 over 3. I'm still not done yet because I'm solving this y equals mx plus b. So instead of m, I'm going to write 4 over 3 x plus, we're already given where our location is. It's that, here's when x is 0, what is y? When x is 0, y is 1. Let's look at number 6. Write an equation in a line that passes through the given points. All right, so now we're not given the graph, we're given a set of points. We're given 2, 3, and 0, 9. And I know that I need to get the equation, so y equals mx plus b. I need to find my m, which is y2 minus y1 over x2 minus x1. And again, I'm kind of going to arbitrarily name these. I could name it whatever way I kind of wanted to. I'll just do x2, y2, x1, y1. So when I plug those in, I get 9 minus 3 over 0 minus 2. And so what that leaves me with 6 over negative 2, which reduces down to negative 3. That's my m. So I go y equals, my m is negative 3 x. I look at my ordered pairs and I say, hey, look at that. They gave me 0, 9. 0, when x is 0, what is y? When x is 0, y is 9. Number 7, we're given 5, negative 2. And we're given 0, negative 2. So whenever I look at this, I say, okay, I need y equals mx plus b. My m equals y2 minus y1 over x2 minus x1. So this is x1, this is y1, this is x2, this is y2. So when I plug this in, I go y2, which is negative 2, minus y1, which is negative 2, all over. My x2 is 0, minus x1, which is 5. Negative, negative make a plus, so negative 2 plus 2 is 0 over 0 minus 5 is negative 5. Wait a minute. 0 over negative 5? 0 over negative 5, 0 divided by anything is 0. So my slope is 0. Okay, so I say, okay, alright, I'll go with it, I'll see what happens. So y equals, my m is 0x plus, when x is 0, what is y? It's negative 2, so actually I shouldn't have put that plus there. So minus 2. And so when I reduce this down, this y equals negative 2. And whenever you see something like this, it kind of should be a little bit of like a, hey, make sure everything makes sense. Whenever you look at 7, whenever you look at the 2 points that we're given 5, negative 2, and 0, negative 2, you notice that the y1 and the y2 are the same number. And so that does tell us, yeah, this should be a straight across line. It should be that y equals 2, negative 2, sorry, forever. Okay. Number 8 and 9. Number 8, in exercises 8 through 9, write a linear function f with the given values. And this one looks a little different. And we kind of have to think back about what we talked about in chapter 3 about this. This equals 3, and then f of 1 equals 5. And so the first thing that I see whenever I see this is I say, well, what's going on here? What's with these parentheses? And I have to think back and I have to remember, oh right, we say like this is f of x. Normally we'd say like f of x equals whatever. In this case, we're kind of given that information. And so what we do is we transform these into a set of ordered pairs. And so you have 0, because that's our x. Whatever's inside this bracket tells us what our x is. And then out here is 3. 0, 3, comma, 1, comma, 5. Because again, this is my x and this is my y. Okay, now that I'm given this, I can work with it a little bit better. And so I have this y equals mx plus b format that I know I need to get it into. I need to figure out my m, which is my y2 minus my y1 over x2 minus x1. I can arbitrarily name these. I'm actually going to name this one x2, y2, and this one x1, y1. And so my y2 is 5 minus my y1, which is 3, divided by my x2, which is 1, minus x1, which is 0. 5 minus 3 is 2. 2. 1 minus 0 is 1. So this winds up being 2. So that's my m. Still not done yet. So I have this y equals 2x plus, am I given an intercept? Yeah, I am. I'm given this 0, 3, and so that tells me that it's 3. Now it specifically asked us to write a linear function f with the given values, and so I'm just going to simply replace this y with f of x. And so I'm going to write f of x equals 2x plus 3. Number 9. F of 0 equals 9, and f of 2 equals 4. So again, I look at this and I say, okay, I need to make this a set of ordered pairs. And so I'm going to set this to 0, 9, and 2, 4. Again, what's with the f, like in here, that's going to be the x value. So I say, okay, I need y equals mx plus b format. My m is my y2 minus my y1 divided by my x2 minus my x1. I can just do this however I want, so I'm just going to make this x1, this one y1, this x2, y2. So my y2 is 4 minus my y1, which is 9, over x2, which is 2, minus x1, which is 0. 4 minus 9 is negative 5 over 2. And that's actually as reduced down as it can go. It doesn't go any smaller than that. Whenever you're doing this, I highly recommend keeping this in a fraction form. It just kind of works out better, especially a little bit later on, whenever we're not given y-intercepts off the bat. So y equals this negative 5 over 2x, and then am I given an intercept? Yeah, I am, 0, 9. So I go plus 9. And again, it asks us to write it as a linear function, so we go f of x equals negative 5 over 2x plus 9. That concludes the notes. Check with your teacher on what your assignment is.